Lesson 12-2, Solving Subtraction Equations. And in this lesson, you learn to solve subtraction equations by using models. When are you ever going to use this? Knowing how to solve equations can help you describe changes in temperature. So you probably have heard about the greenhouse effect on Earth. Did you know that it also affects other planets? Scientists have determined that on Mars, the difference between the air temperature and the greenhouse effect and what it would be if it weren't for the greenhouse effect is 5 degrees Fahrenheit. So suppose the temperature would be negative 3 degrees Fahrenheit on Mars. If it weren't for the greenhouse effect, what is the air temperature with the greenhouse effect? Okay, so we will solve this problem in example 1. So let's refer to the beginning of the lesson. What would be the temperature with the greenhouse effect? Again, a word problem. We need to define a variable and we need to use a let statement. So we let G represent the temperature with the greenhouse effect, G representing greenhouse. Okay, translate the problem into an equation using the variable G, then model the equation and then solve. So the temperature with the greenhouse effect, we represented that with G minus, okay, the actual temperature, which is negative 3, equals the difference, which is equal to 5. Okay, so rewrite this particular equation. We have too many minus signs there. So we rewrite the addition equation. Remember that subtracting in an integer is the same as adding its opposite. So when you're subtracting an integer, you're actually adding the opposite of negative 3. So G minus negative 3 is actually the same as G plus 3 equals 5. So G minus negative 3 equals 5 is same as G plus 3 equal to 5. And then we use a cup to represent G. Add 3 positive counters on the left side of the mat to represent plus 3. Okay? Then place 5 counters on the right side of the mat to represent plus 5. Okay? So now we have G plus 3 is equal to 5. Okay? So we want to isolate our cup. So to get the cup by itself, remove 3 positive counters from each side. Okay? Remember, whatever you do to one side of the equation, you need to do to the other side. So if we remove 3 positive counters from the left side, we need to remove 3 positive counters on the right side as well, like what we have here. Remove 3 counters here, remove 3 counters here. Okay, we end up with 2. So the solution is 2. The temperature with a greenhouse effect is 2 degrees Fahrenheit. Okay, so here G is isolated and the only positive counters left, okay, are 2. Okay, so checking this, we get our G and substitute it back to our original equation right there. So we have G minus negative 3 equals 5. Substitute G with 2. So this becomes 2 minus negative 3. Is it equal to 5? We replace G with 2. And then we know that this is an addition statement. When you're subtracting, you're adding its opposite. So this becomes 2 plus 3. Is it equal to 5? And indeed it is. So we have checked our equation. Okay, let's take a look at example number 2. Use cups and counters to solve H minus negative 4 equals negative 3. Again, we want to rewrite this equation into an addition equation. Okay, so we have H minus negative 4 is equal to negative 3 is the same as H plus 4 equals negative 3. Remember that when you're subtracting, you're adding its opposite. So when you're subtracting, you're adding its opposite. You're adding the opposite of negative 4, which is 4. Okay? And from there, we use a cup to represent H. Okay? Add 4 positive counters beside the cup on the left side of the mat to represent plus 4. So what we have, so this is H plus 4. Place 3 negative counters on the right side of the mat to represent negative 3. Okay, so if you look closely, you need to isolate the cup by removing 4 positive counters. The problem is you cannot remove 4 positive counters on the right side. Okay, so this is H plus 4 equals negative 3. To get the cup by itself, we need to remove 4 positive counters. Since there are no positive counters on the right side of the mat, we need to add 4 negative counters to each side to make 4 zero pairs on the left side of the mat. So for us to get rid of the 4 positive counters, we need to add 4 negative counters, okay, to each side so that we can isolate that cup. And remember, once we add 4 negative counters here, we need to add 4 negative counters at the same time. And then we remove our zero pairs like what you see here. Okay, we added 4 negative counters, which makes up 0 pairs, and we removed all our 0 pairs. And since we added 4 negative counters here, we need to add 4 negative counters here as well. Okay, and now this becomes h plus 4 plus negative 4 because we added 4 negative counters, and this becomes negative 3 plus negative 4. We've isolated our cup, and now we have negative 3 plus negative 4 will give us negative 7. Okay, so h is equal to negative 7. Checking our solution, okay, we simply substitute h with negative 7. So negative 7 minus negative 4 is equal to negative 3. Make it into an addition statement. This becomes negative 7 plus 4 is it equal to negative 3, and indeed it is. So we've checked our solution to be correct at negative 7. Okay, let's take a look at example number 3 and see how this works. Use cups and counters to solve x minus 6 equals negative 2. So first rewrite as an addition equation. Again, when we're subtracting, we're adding its opposite. So we're basically adding the opposite of 6, which is negative 6. So this basically becomes, when you want to write this, x minus 6 equals negative 2 is the same as x plus negative 6 equals negative 2. So use a cup to represent x, add 6 negative counters on the left side of the mat to represent negative 6, as what you have here. Okay, and then place 2 negative counters on the right side of the mat to represent negative 2. Okay, so we want to get rid of our negative 6 counters. Okay, so here you have x plus negative 6 equals negative 2. And to get the cup by itself, we want to remove 6 negative counters from each side. But if you notice, we can remove 6 negative counters here, but we cannot remove 6 negative counters here because it's not enough. Okay, so since there are not enough negative counters on the right side of the mat, add 6 positive counters to each side. So we want to add 6 positive counters here, so we'll have 6 zero pairs. Okay, then remove all our 0 pairs. So remember, when we add 6 positive counters here, we need to add 6 positive counters to the right as well. And this is what we get. So we added our 6 positive counters and we took out 0 pairs, and that means we need to add 6 positive counters here as well. And if you notice, when we added 6 positive counters, we have 2 0 pairs, and we simply took out the 2 0 pairs. So this is actually x plus negative 6 plus 6 is equal to negative 2 plus 6. Okay, whatever you add to one side, we need to add to the other side because it's an equation. And then we now have our cup by itself, and we have 4 positive counters here. So x is equal to negative 4. Okay, so basically, if we want to check if our answer makes sense or not, x minus 6 equals negative 2, we simply substitute the value of 4 to our x. So this becomes 4 minus 6 is equal to negative 4. Make it into an addition statement. 4 plus negative 6 is equal to negative 2. And the answer is, yes, our answer checks out. So the solution is 4. Okay? And let me show you another way of doing this. And let's go back to the same thing. Same example. So without using counters, if you have x minus 6 is equal to negative 2, okay, another way of looking at this is we want to undo negative 6, because if we make it into a addition sentence, this is x plus negative 6 is equal to negative 2. So in order to undo negative 6, we need to use inverse operations. So in this case, to be able to undo negative 6, we need to add 6. Okay, so the inverse operation of subtraction is addition. So you have subtraction here, inverse operation is addition. So remember, it's an equation, And the subtraction property of equality simply states this, that if you have A is equal to B, okay, then A minus B is equal to is equal to let me rewrite that, if A is equal to B and A minus C is equal to B minus C. Okay, so that is the subtraction property of equality. Whatever you subtract to one side, you need to subtract to the other side. And the addition property of equality states, if you recall, if A is equal to B and A plus C is equal to B plus C. So whatever you add to one side, you need to add to the other side. So following those properties of equality, since we added 6 to this side of the equation, we need to add 6 to this side as well. Okay, and when we add 6 to this side, you now have negative 6 plus 6 will give you 0. That leaves you with x. And negative 2 plus 6, from what we learned in adding integers, this is positive 4. Okay, shorter method of doing this without models. Okay, let me give you another example. Let's say I have y plus 7 is equal to negative 6. Okay, again, we need to undo 7. And to be able to undo 7, we need to do our inverse operations. And the inverse operation of addition would be subtraction. So we simply subtract 7. And according to our properties of equality, the subtraction property of equality, if we subtract 7 to one side, we need to subtract 7 to the other side as well. Okay, and we end up with y equals negative 6 minus 7 is the same as negative 6 plus negative 7. So this is the same as negative 13. So y equals negative 13. Okay, hopefully that makes sense. And the secret word for this particular lesson would be Starbucks. Secret word would be Starbucks. Okay, thank you for watching.